Hello everyone, SimCFI here, and today we're going to cover the Sperry A3 Autopilot and the navigation systems on the A2A Constellation. Welcome to the flight deck. It's a four-man crew. You got pilot, you got captain, first officer, flight engineer, and navigator behind the captain. Alright, so we're cruising along here at 6,500 feet over Southern California. And so using the autopilot, the very first step is you want to make sure you get the airplane trimmed out for a hands-free flight like this. Now, brief intro on this autopilot. I'm just going to read from the manual here. So the automatic pilot, gyro pilot, equipment consists of a directional gyro control unit, a bank incline gyro control unit, a mounting unit, and a servo unit, together with the necessary accessories for the proper working of the equipment as a whole. When the automatic pilot is set to fly the airplane in straight level course, and this attitude is disturbed by a gust of wind or otherwise, the gyros in the control units operate the air pickoffs so that a difference of pressure is obtained across the diaphragm and the air relays. This causes the balanced oil valves to open and not allow oil to flow to the servo unit. This oil is under pressure and moves the piston and the servo in the direction that will cause a corrective movement of the airplane's control surface. This movement causes the airplane to assume its original straight level flight position. And then when a maneuver is desired, the indices on the control units are moved slowly by the knobs until the maneuver is complete. When the indices are moved, a difference in pressure across the diaphragm and the air relays will result. This will operate the balanced oil valves and allow hydraulic fluid to flow to the servo. The servo will then move the controls so that the desired maneuver is performed. Alright, so that's the background on how this autopilot works. It's basically gyros and servos shifting air and oil pressure around to make the controls move, basically. So, we got straight and level flight, hands-free. Not going to crash into any one of these mountains. And so, first of all, it's default to on, but you got to make sure the autopilot is actually turned on right here with the switch. Switch back to the captain's seat. Okay, then the next step is to make sure you align all these control indices. So here we have the rudder index, and we have index, and we have the aileron index, and then the elevator index. And so moving the rudder index, you see the card moving on top. And you want to make sure it lines up with the heading on the bottom. So those are aligned, and then the aileron, you want to make sure that's aligned. Right now the airplane is getting turbulence. Of course, roll that back. Okay. Realign this real quick. So that's aligned, this is aligned to aileron. You see the little tab here on top of the bank that's moving. So make sure that's aligned. And the elevators on the side over here, make sure this is aligned. There we go. And I'm just using the mouse wheel to move these indices around here. So now once you want to actually, little pause, when you actually want to engage the autopilot, come down here to these controls down here, these three levers. You have rudder, aileron, elevator. So let's go ahead and activate all of them. And now they're going to follow the indices that we have set. And right now we're just fighting that turbulence too, but now it's maintaining roughly the altitude we want. Remember, it's not an altitude hold, it's just going to hold really the kind of the pitch that we want. So we want to get a little bit forward elevator, so I'm just going to come over to the elevator index and mouse wheel forward, and you see the yoke starts being pushed down. Okay. So it's an autopilot, but sometimes it tends to be that hand flying. It is almost easier, but it can relieve you to be able to do some other tasks. Okay, so now we want to level off, so mouse wheel down to get it back up a little bit. Okay, so now let's say we need to change heading. So right now, looking at the RMI, the remote magnetic indicator, we're on a heading of 180. Let's say we want to make a right turn to a heading of 240. So we come over here to the rudder index and move this over to 240. Pause. Now I see the airplane is turning. Okay, and so it's also applying the aileron to bank the plane, the rudder to keep kind of coordinated, the ball's kicking out, and it provides a little bit of back pressure on the elevator, but right now it's doing too much. So kind of scroll it down a bit. This is where you can run into some trouble if you're doing this, while under ATC control, you gotta maintain that heading control. So when you make a turn, I would be ready to make some corrections on the elevator index as well. So now it's going down too much, might have also hit a downdraft, but let's pull this thing back up. So yeah, working the autopilot is almost harder than flying the airplane. Coming into this cloud. Active sky next with soft clouds. Okay, so see, now we're established on a heading of 240. We're still roughly at the altitude we want to be, and still flying hands-free. So that's the general purpose of this autopilot. It's very basic. Okay, so now let's get into a little bit of the navigation. So this airplane, just like the A2A Stratocruiser, the Boeing Stratocruiser, it's got an RMI, a remote magnetic indicator, and this can track your radials and bearings to and from the VORs. It can also track ADF as well. You select LF for low frequency up here, and the needles will point to your ADFs that you tune, which are up here, I believe, on the overhead. But for today, let's get into the VOR, this tracker reset. So right now we're just near Santa Monica. We're going to make a right-hand turn. So let's crank this all the way around. Big U-turn. Let's go north, and as we're doing that, I'll show you where we are. So right now we're right around here, Santa Monica, turning northbound, and we'll start picking up some of these VORs that's tuned in. So let's tune in Fellows VOR DME on 17.5. Should have DME. Let's hope it has DME this sim. Getting into the cloud here. Okay, and see it's pitching us up, so kind of mouse wheel forward. So get the pitch down a little bit. Okay, so we need to tune 17.5. So that's going to be down here on nav 1.
Pressurization set.
So I'm just going to use the mouse whiz on these two knobs. The big knob changes the large frequency number, so 17. And then we want 0.5, so use the small knob. Right there, the 17.5. And now you see that brown needle swing. Nav 1 is connected to the brown needle. I'm not going to worry too much about altitude right now. Still in a little bit of IMC. So just using the RMI alone, it's pointing to the station right now. So it's saying if you want to go directly to the station, we have to fly a heading of 035. And right now, we are on the 215 radial. But since it's aligned off here like this, it's probably going to be changing over time. You can see this needle is slowly moving right. And so if we want to go directly to the station, all we have to do is turn towards it. So let's choose heading of 040 on the autopilot. Right there. Maybe a little bit past. And now we'll be going straight to the station. And now with the Stratocruiser, this is all we had. You know, you just had the RMI. And you can accurately fly your bearings and radials with this. But with the Constellation, they've also given us DME, which is right down here above the suction gauge. Right now it's connected to VOR1. So right now it's saying we're 23 miles, and see it's slowly decreasing as we start flying to the station now. There we go. The plane's not getting bumped around and torn apart by turbulence. Okay, so we got DME, and another cool thing they got is this gauge right here, the localizer range. We can tune the magnetic bearing to here, so let's put 040. And now you can use it just like a traditional VOR that you used to in all of the GA planes. So the RMI almost takes a back seat, kind of primarily flying with this to really maintain the course accuracy if you're not used to the RMI. So you got this and this combined with your DME, and you should be pretty comfortable flying a lot of slant A procedures, basically. But like I said, you can do all that with just the RMI as well. Obviously you're not going to get DME, so if there's any approach or any procedure that requires DME, you're not going to be able to do that on the Stratocruiser, but the Constellation is no problem. And see, that automatic pilot's doing a pretty good job here. Let's go ahead and mouse wheel back. Pitch it back. And there's a little turbulence. Okay, so let's say we want to fly outbound on the 240 radial. So first let's tune in. So right here, see we're flying to the station, and you can see how there's a to and from and off flag here too. So right now it's pointing to the to flag, so that gives us that info. But let's tune this to 240. And you see it goes to from, because we've selected a bearing, we've selected a heading that's going to take us from the station. So now, what we need to do is we need to, let's first at least turn to a heading that kind of makes sense. So we're still going to the station, 240 is here, so let's start turning it around at least. But the concepts you need to use when using a bearing pointer like this, kind of like with ADF as well, which you can do if you set your ADF up here at LF, is you need to push the head and pull the tail to make it track the course you want, and it'll make a little bit more sense once we get this thing spun around here. But I just use the autopilot to turn, and aside from the turbulence, we're doing all right maintaining altitude. And in the manual, it just states to kind of reset the autopilot every 2 hours or so, because they're all gyro units. The gyro is precessed just like your gyroscopic instruments. I don't know if that's simulated in here or not, but that's what it says. But this is a really nice plane. The radio engines sound really good in cruise and on the ground, low RPM. And it's running really smoothly with the track IR. Right now I've got the flight engineer doing all the work, but I think from the Stratocruiser it's a much simplified flight engineer station. I think this is a newer plane from the Stratocruiser real world anyway, so it's actually quite easy to man all the stations essentially by yourself. I've already done one flight where I did all the flight engineer stuff, and it's actually quite easy compared to the Stratocruiser. Alright, so we're turned around now, and we want to fly the 240 bearing outbound from the station. Right now we're on the 230 radial. You can see over here we've selected 240 it's from. You can see here we have to go to the right, but imagine for a second we didn't have that, so now we have to pull the tail. So this heading that we're on right now will actually do it just fine. See, it's slowly moving to 240, so we're pulling the tail. But if you want to move it faster, let's just turn the airplane right a little bit more. We'll choose a heading over here, like the 300 range, or 280, and that's going to pull this tail faster, and we'll get to the 240 radial. And you see this gauge is starting to come in, the needle's starting to center, so we're within 5 degrees now. So let's go ahead and turn it back. Let's just put 240 on the autopilot. Right now we're 19 miles. Should be going up to 20, so we're flying away from the station. Let's stop that turn for a second. As you can see, we've been pulling that tail, and it's getting a lot closer to 240. And you can track your courses like this. And then obviously, since we have another pause, we have this gauge here, we can also fly a localizer or ILS course. You can also fly with DME, you can fly your DME arcs, and actually with an RMI, the DME arc is really easy because you just keep the needle basically 90 degrees due left or right of you, and that's 90 degrees off where the station would be, and you're flying your DME arc just like that. Okay, so now you can see we have a little bit of an intercept. This is pretty much centered. This is pretty much headed in 2-4. So now to continue flying, I don't know what the winds aloft are right now, but let's just throw this back on 2-4 roughly, maybe a little bit shy of it. And we'll be on the 240 outbound. So this is how you fly your radios. Obviously flying to the station works the same way with the head, but with the head you want to push the head. So let's spin it around again. So now that we're tracking a radio, and obviously you can set another VOR, and you can track multiple. You can use your cross radials. So let's set another one. I'm going to set. So we're still sitting around Santa Maria. So let's go ahead and set the Morro Bay VORTAC on 112.4. So down here in nav 2, we're tuning 112.4. And now the green needle centers up. Right now we're actually flying straight to it. Keep turning around so we're flying to the Fellows VOR, the first one we tuned. You get fly heading of 060, so we're flying to it. And this makes it easy to see what radio you're on from a second VOR. So if you wanted to use a cross radio, like let's say you wanted to know when you're going to cross the 110 radio from Morro Bay, well right now this is showing you that. So if you want to see, if you're using a cross radio in flight, you'll be able to see it progressing. Like let's say you're waiting for the 1.5 radio. With this type of gauge, if the needle's fully deflected, it takes a little bit of thinking to see, okay, how much longer until I actually cross it. But with this, you can really see it moving and progressing. So the RMI, being an older instrument, still has its advantages and uses today. And I think they got, an RMI. It doesn't look older like this, but they got RMIs on the 737s too, on the NGX. PMDG, I've seen it, so it makes its way to modern airplanes too. But now I'm turning it so we're flying to Fellows, I think it was called. Yep, Fellows. I'm just looking down at my iPad, which I have the position linked up on the flight sim, which is pretty cool. Okay, so now we're flying to, let's say we want to fly a different bearing inbound. Let's say we want to, instead of the 070 inbound, we want the 090 inbound. Well, we have to push the head, so we need to choose a heading around here, like north, and that'll push the head. So let's turn the airplane left to north to make this thing go faster. So we were already at an intercept, technically, like a 10-degree intercept, but obviously that's going to make it move really slowly. Okay, so we're going to turn over here to get a larger intercept. And what's going on is we're on the 25... the 25. We're on the 250 radio off of Fellows right over here, and so that's given us the 070 inbound. We want to fly the 090 inbound, I think is what we said. Yep, the 090 inbound. So you can see if we're flying inbound, we have to be up here on the 270 radio, not the 260 radio or 250 radio. And so we're just moving ourselves up, and you can see how it's going to push this head. So remember, push the head like this, or drag and pull the tail. And that's how you fly your bearings and radios accurately with an RMI. And so, because of how well this airplane is equipped with even this basic autopilot and this
pressurization is set.
Relatively good navigation instrumentation, I'll be doing some of the IFR flights with this airplane on Pilot Edge. I'm just doing some practice flights on Pilot Edge to get everything set up to make sure the videos are good. Okay, but now you can see we were flying the inbound 070, now it's at 076, and so it's moving to 09. So we're making our way northbound to re-intercept a new bearing inbound. And so once we get that done, that basically completes the video. We talked about the autopilot. Remember, these are the switch to turn on the autopilot. Just press A to switch views to the co-pilot seat, and here's your master switch. Press A twice to get to the flight engineer station. Press A another time to get to the navigator. And a little thing, your radio master switch to turn on your radios and all that is way back here, behind the navigator. So you gotta flick that switch on if you do cold and dark by yourself. And then just Shift A, Shift A, Shift A, back up here. Now we're at the 085 bearing, so we fly a little bit more, but so autopilot on. Make sure you set up your indices. This is your rudder index right here. This is your aileron index right here, and your elevator index right here. Make sure those are neutral and lined up with each other, and then you can safely engage all three levers of the autopilot, or whichever ones you want individually. And then you just use these indices to change the desired settings. Another thing about the autopilot I wanted to show that I forgot is the servo speeds. They're all default to 3. And so basically how fast you want the servos to move, you can govern right here. If you don't want to move them at all, you just move it down to close to 0. So see, if I have it to 1 and I command a heading change, you see the airplane's not really doing it. It might be doing it, yeah, it's doing it slowly. And so you can change the speed of how this works. And so this is a good time. See, now we're at the 090, so let's command to turn to 090. And you see we're tracking the 090 inbound on the brown needle to Fellows. The green needle is Morro Bay, which are on the 080 radial. So you can get all this info really quickly. And so this one is tuned to Fellows, so we'll put this back to 090. Go. You can see how we're still established on the airway, if it was an airway. And you can also change this, so this gauge, and the DME can be linked to VOR2 as well. So Morro Bay, we're 25 miles away from Morro Bay, and we're 10 miles away from Fellows. So a lot of power you got here. Like I said, if you want to make either one of these needles an ADF, you just flick these switches here. But I got them set to VORs right now. Alrighty. Well, that pretty much does it for the basic navigation and autopilot usage in the A2A Simulation Stratocruiser. Looking forward to do some full flights with this thing, IFR and Pilot Edge. See you next time.